analysis quickly within design environments. Now you can clearly see and thoroughly understand multiple interrelated aspects of a building's performance parameters before construction. Insight extends the capabilities and value of the Autodesk AEC collection through unprecedented levels of cloud-based performance analysis. Discover Autodesk Insight and discover all the power of the AEC collection. Maximize your BIM workflows with Autodesk Insight, a powerful cloud-based analysis tool in the AEC collection. Autodesk Insight helps you improve energy and environmental performance throughout the building lifecycle by letting you integrate energy analysis, lighting analysis, and solar analysis for a holistic approach to building performance design. Make smarter design decisions using Insight's cloud-based analysis tools to iterate and optimize project parameters during the design phase. For example, use Insight to automatically create energy models from Revit, from concept to detailed design, access analyses and visualizations directly in the modeling environment. Visualize and interact with key performance indicators, factors, ranges, and specifications with real-time cause and effect feedback. Quantify and visualize heating and cooling loads. Perform sun and shadow studies to accurately see how lighting conditions affect your model. Simulate daylighting and glare. Access solar PV performance analysis quickly within design environments. Now you can clearly see and thoroughly understand multiple interrelated aspects of a building's performance parameters before construction. Insight extends the capabilities and value of the Autodesk AEC collection through unprecedented levels of cloud-based performance analysis. Discover Autodesk Insight and discover all the power of the AEC collection. Maximize your BIM workflows with Autodesk Insight, a powerful cloud-based analysis tool in the AEC collection. Autodesk Insight helps you improve energy and environmental performance throughout the building lifecycle by letting you integrate energy analysis, lighting analysis, and solar analysis for a holistic approach to building performance design. Make smarter design decisions using Insight's cloud-based analysis tools to iterate and optimize project parameters during the design phase. For example, use Insight to automatically create energy models from Revit, from concept to detailed design, access analyses and visualizations directly in the modeling environment. Visualize and interact with key performance indicators, factors, ranges, and specifications with real-time cause and effect feedback. Quantify and visualize heating and cooling loads. Perform sun and shadow studies to accurately see how lighting conditions affect your model. Simulate daylighting and glare. Access solar within design environments. Now you can clearly see and thoroughly understand multiple interrelated aspects of a building's performance parameters before construction. Insight extends the capabilities and value of the Autodesk AEC collection through unprecedented levels of cloud-based performance analysis. Discover Autodesk Insight and discover all the power of the AEC collection. Maximize your BIM workflows with Autodesk Insight, a powerful cloud-based analysis tool in the AEC collection. Autodesk Insight helps you improve energy and environmental performance throughout the building lifecycle by letting you integrate energy analysis, lighting analysis, and solar analysis for a holistic approach to building performance design. Make smarter design decisions using Insight's cloud-based analysis tools to iterate and optimize project parameters during the design phase. For example, use Insight to automatically create energy models from Revit, from concept to detailed design, access analyses and visualizations directly in the modeling environment. Visualize and interact with key performance indicators, factors, ranges, and specifications with real-time cause and effect feedback. Quantify and visualize heating and cooling loads. Perform sun and shadow studies to accurately see how lighting conditions affect your model. Simulate daylighting and glare. Access solar PV performance analysis quickly within design environments. Now you can clearly see and thoroughly understand multiple interrelated aspects of a building's performance parameters before construction. Insight extends the capabilities and value of the Autodesk AEC collection through unprecedented levels of cloud-based performance analysis. Discover Autodesk Insight and discover all the power of the AEC collection. Maximize your BIM workflows with Autodesk Insight, a powerful cloud-based analysis tool in the AEC collection. Autodesk Insight helps you improve energy and environmental performance throughout the building lifecycle by letting you integrate energy analysis, lighting analysis, and solar analysis for a holistic approach to building performance design. Make smarter design decisions using Insight's cloud-based analysis tools to iterate and optimize project parameters during the design phase. For example, use Insight to automatically create energy models from Revit, from concept to detailed design. Access analyses and visualizations directly in the modeling environment. Visualize and interact with key performance indicators, factors, ranges, and specifications with real-time cause and effect feedback. Quantify and visualize heating and cooling loads. Perform sun and shadow studies. How lighting conditions affect your model. Simulate daylighting and glare. Access solar PV performance analysis quickly within design environments. Now you can clearly see and thoroughly understand multiple interrelated aspects of a building's performance parameters before construction. Insight extends the capabilities and value of the Autodesk AEC collection through unprecedented levels of cloud-based performance analysis. Discover Autodesk Insight and discover all the power of the AEC collection. Maximize your BIM workflows with Autodesk Insight, a powerful cloud-based analysis tool in the AEC collection. Autodesk Insight helps you improve energy and environmental performance throughout the building lifecycle by letting you integrate energy analysis, lighting analysis, and solar analysis for a holistic approach to building performance design. Make smarter design decisions using Insight's cloud-based analysis tools to iterate and optimize project parameters during the design phase. For example, use Insight to automatically create energy models from Revit, from concept to detailed design. Access analyses and visualizations directly in the modeling environment. Visualize and interact with key performance indicators, factors, ranges, and specifications with real-time cause and effect feedback. Quantify and visualize heating and cooling loads. Perform sun and shadow studies to accurately.
Good afternoon, everyone. We will be starting in a few minutes. Thank you.
Environments. Now you can clearly see and thoroughly understand multiple interrelated aspects of a building's performance parameters before construction. Insight extends the capabilities and value of the Autodesk AEC collection through unprecedented levels of cloud-based performance analysis. Discover Autodesk Insight and discover all the power of the AEC collection. Maximize your BIM workflows with Autodesk Insight, a powerful cloud-based analysis tool in the AEC collection. Autodesk Insight helps you improve energy and environmental performance throughout the building lifecycle by letting you integrate energy analysis, lighting analysis, and solar analysis for a holistic approach to building performance design. Make smarter design decisions using Insight's cloud-based analysis tools to iterate and optimize project parameters during the design phase. For example, Use Insight to automatically create energy models from Revit, from concept to detailed design. Access analyses and visualizations directly in the modeling environment. Visualize and interact with key performance indicators, factors, ranges, and specifications with real-time cause and effect feedback. Quantify and visualize heating and cooling loads. Perform sun and shadow studies to accurately see how lighting conditions affect your model. Simulate daylighting and glare. Access solar PV performance analysis quickly within design environments. Now you can clearly see and thoroughly understand multiple interrelated aspects of a building's performance parameters before.
Good afternoon, everyone. We'll be starting in few minutes. Thank you.
Performance analysis. Discover Autodesk Insight and discover all the power of the AEC collection. Maximize your BIM workflows with Autodesk Insight, a powerful cloud-based analysis tool in the AEC collection. Autodesk Insight helps you improve energy and environmental performance throughout the building lifecycle by letting you integrate energy analysis, lighting analysis, and solar analysis for a holistic approach to building performance design. Make smarter design decisions using Insight's cloud-based analysis tools to iterate and optimize project parameters during the design phase. For example, use Insight to automatically create energy models from Revit, from concept to detailed design. Access analyses and visualizations directly in the modeling environment. Visualize and interact with key performance indicators, factors, ranges, and specifications with real-time cause and effect feedback. Quantify and visualize heating and cooling loads. Perform sun and shadow studies to accurately see how lighting conditions affect your model. Simulate daylighting and glare. Access solar PV performance analysis quickly within design environments. Now you can clearly see and thoroughly understand multiple interrelated aspects of a building's performance parameters before construction. Insight extends the capabilities and value of the Autodesk AEC collection through unprecedented levels of cloud-based performance analysis. Discover Autodesk Insight and discover all the power of the AEC collection. Maximize your BIM workflows with Autodesk Insight, a powerful cloud-based analysis tool in the AEC collection. Autodesk Insight helps you improve energy and environmental performance throughout the building lifecycle by letting you integrate energy analysis, lighting analysis, and solar analysis for a holistic approach to building performance design. Make smarter design decisions using Insight's cloud-based analysis tools to iterate and optimize project parameters during the design phase. For example, use Insight to automatically create energy models from Revit, from concept to detailed design. Access analyses and visualizations directly in the modeling environment. Visualize and interact with key performance indicators, factors, ranges, and specifications with real-time cause and effect feedback. Quantify and visualize heating and cooling loads. Perform sun and shadow studies to accurately see how lighting conditions affect your model. Simulate daylighting and glare. Access solar PV performance analysis quickly within design environments.
Good afternoon, everyone. So a lot of people are still joining, so we'll wait for a few minutes. We will be starting shortly. Thank you.
Extends the capabilities and value of the Autodesk AEC collection through unprecedented levels of cloud-based performance analysis. Discover Autodesk Insight and discover all the power of the AEC collection. Maximize your BIM workflows with Autodesk Insight, a powerful cloud-based analysis tool in the AEC collection. Autodesk Insight helps you improve energy and environmental performance throughout the building lifecycle by letting you integrate energy analysis, lighting analysis, and solar analysis for a holistic approach to building performance design. Make smarter design decisions using Insight's cloud-based analysis tools to iterate and optimize project parameters during the design phase. For example, use Insight to automatically create energy models from Revit, from concept to detailed design. Access analyses and visualizations directly in the modeling environment. Visualize and interact with key performance indicators, factors, ranges, and specifications with real-time cause and effect feedback. Quantify and visualize heating and cooling loads. Perform sun and shadow studies to accurately see how lighting conditions affect your model. Simulate daylighting and glare.
Good afternoon, everyone. So we will start in 2 minutes sharp. Thank you.
Now you can clearly see and thoroughly understand multiple interrelated aspects of a building's performance parameters before construction. Insight extends the capabilities and value of the Autodesk AEC collection through unprecedented levels of cloud-based performance analysis. Discover Autodesk Insight and discover all the power of the AEC collection. Maximize your BIM workflows with Autodesk Insight, a powerful cloud. Insight helps you improve energy and environmental performance throughout the building lifecycle by letting you integrate energy analysis, lighting analysis, and solar analysis for a holistic approach to building performance design. Make smarter design decisions using Insight's cloud-based analysis tools to iterate and optimize project parameters during the design phase. For example, use Insight to automatically create energy models from Revit, from concept to detailed design. Access analyses and visualizations directly in the modeling environment. Visualize and interact with key performance indicators, factors, ranges, and specifications with real-time cause and effect feedback. Quantify and visualize heating and cooling loads. Perform sun and shadow studies to accurately see how lighting conditions affect your model. Simulate daylighting and glare. Access solar PV performance analysis quickly within design environments. Now you can clearly see and thoroughly understand multiple interrelated aspects of a building's performance parameters before construction. Insight extends the capabilities and value of the Autodesk AEC collection through unprecedented levels of cloud-based performance analysis. Discover Autodesk Insight and discover all the power of the AEC collection.
Good afternoon, everyone. Uh, Welcome to the online workshop on Revit and energy analysis. I'm Farhad. I'm an architect. I work for Capricorn as BIM evangelist. And this workshop is a part of Designaddvance event, and our knowledge and technology partner is Autodesk and competition partner is Ethos. So following are the program details. So first we'll have a quick poll, then we'll have welcome note by Mr. Chakresh Jain. Then we'll discuss the details on Designaddvance competition. Then our guest speaker, Mr. Amin Nair, will take his presentation. And after Mr. Amin Nair's presentation, we'll have a question and answer session related to sir's presentation. So you guys need to put in your question in the Q&A box. I am going to read the questions, and so whenever a question pops up in your mind, just put it in the Q&A box. After that, we'll have the shadow analysis. We'll see a demo on the shadow analysis using Revit, then the energy simulations using Revit by Mr. Nazim. And then we'll have again one more Q&A session for the demo sessions. And then a vote of thanks by Mr. Amit Jain. Okay, so I'll quickly launch the poll, and I request everyone to please participate in the poll. So it's about your background, so that this sets the tone for the event. Okay, so I'm just launching the poll, and it'll be open for 30 seconds. So I request everyone, please participate. So as you can see, I've launched the poll. There are 3 options, whether you are an architect, engineer, or from your profession is other. So please guys participate. I'll end this poll in 5 seconds. 3, 2, 1, ending the poll. Okay, I'll just share the results. So here 52% of participants are architects, 40% are engineers, and 8% are from the other background, professional background. Thank you for taking part in the poll. Moving on. Okay, so I would like to introduce Mr. Chakresh Jain. So Mr. Jain is the chairman of board at Capricorn Technologies Private Limited, and he did architecture from IIT Kharagpur and started at AutoCAD and training consultancy services just after the graduation. So over to you, Chakresh sir.
Thank you, Farhad. Am I audible?
Yes.
Okay. So thank you and welcome everyone for on this workshop which we are conducting on. So today so much has been discussed about BIM and what we wanted to bring, that what are the additional things which we are doing today very easily under BIM is the and how to do those things is what we wanted to bring today. So I'll not take much time on the actual workshop. We'll just take 2 slides about us. So I love to talk about our organization. Next slide, please. Yeah. So we've been supporting the construction industry for over 3 decades, and with all the effort which we have put in, today we are able to have more than 20,000 customers from construction industry like yourself. And today we are present in about 10 different locations across the country, and our team size is about 250 people. Next slide, please. So what we do is that our main forte is in construction industry, but we also work with a lot of other adjacent design industry like manufacturing, multimedia and entertainment. We also work with government, and we work with educational institutes, and today we have a lot of students attending, and we do provide a lot of services. But one of the important thing learning for us, what I like to highlight is that we find that the design process is very similar in all these industries, but some of the industries are slightly ahead of other industry, but very soon we find that some of the good practices of that industry gets replicated in other industries, and that's where we find a big advantage of working in so many industries, and we are slightly aware about what's happening in all these industries in design. Next slide, please. So as a solutions, our biggest partnership is with Autodesk, and we are Autodesk Platinum partner and also Autodesk training center. But then we know that one company solution will not be able to suffice all the need of the users, diverse users like yourselves. So we have partnership with very adjacent solution companies like architects especially love to use Photoshop, and that's why we have partnership with Adobe. Then and of course for rendering, V-Ray uh, is very well known. And then we also have a local solution, Trazy, which is a very good VR solution where you can take the 3D model of Revit and then do a lot of virtual walkthrough and a lot of work within that. So apart from these solutions, we are also now part of RIB group company. We work with Bentley, Trimble, and for GIS, we work with ESRI. Then we also have solutions which are used in manufacturing for 3D printing with HP solutions for your computing and graphic printing, and MathWorks, which is in educational institute. So with that, I like to hand over back to Farhad. So these are our board members present in 4 different locations. Yeah. Thank you. And I like to hand over back to Farhad.
Thank you, sir. Now I would like to invite Shruti from Ethos India. So Shruti will explain about the Designaddvance competition this workshop is a part of. Over to you, Shruti.
Thank you, Farhad. So, hello everyone. A very good afternoon. I am Shruti from Ethos. So, the COVID-19 pandemic brought the world to a halt almost a year ago. It had brought on the imposition of a stringent lockdown in March last year. While life has changed now in many ways that we could not have foreseen, there were other important turn of events that had occurred. So, in the initial months, we saw the mass exodus of migrants, and this took the center stage on all news stories. With their worsened socioeconomic situation and lack of decent living conditions, their stories of suffering became the face of many Indian cities. I am sure at some point all of us questioned ourselves about the things that we could do to make it better and how we could contribute to improve the living conditions of these migrant workers. So we worked on this premise to bring to you a design challenge with the social impact in mind. Designaddvance livable spaces for the nowhere people has been launched by Capricorn in association with Autodesk and Ethos. So this is a call for interventions to design livable spaces for our migrant workers, spaces that would be adaptable, sustainable, resilient, and innovative. The competition is open to all undergraduate and postgraduate students of architecture and design. We are looking for solutions which would be human centric with specific design approaches at a micro and a micro level on the sites chosen by the participants. These solutions would need to promote dignity, security, and safety of all such nomadic residents in an urban context. You can register and check the complete design brief on the website designaddvance.in. We hope you participate and help us spread the word about this call for ideas. Thank you. Over to you, Farhan.
Thank you, Shruti. Now moving on. So I would like to introduce architect Amin Nair. So Mr. Mohammad Amin Nair is a renowned architect with more than 2 decades of international experience. In 1995, he graduated from SPA Delhi, where he was part of research conducted in bioclimatic architecture with Bartlett School of Architecture. He has been a visiting faculty at SPA Delhi, Vastukala Academy, and Sushan School of Architecture. He established ANA Design Studio Private Limited in 1996, a full-fledged architecture, engineering, and project management firm with projects across India, West Asia, and Africa. He ensures that both are closely knit right from the beginning with a vision to improve upon implementation. Under his leadership, the firm has delivered some prominent projects such as Reliance Technology Group, India's largest private sector laboratory with 48 super specialty labs in an area of 5 lakh square feet in Mumbai, India's first lead global certified lab, India's first lead gold cash and carry Carrefour in Meerut in 2014. Currently, he is leading projects across India and Africa, of which landmark village development, a 3 million square feet waterfront in Lagos, Nigeria, is a prestigious one. Another is for pleasure in India and ongoing railway equipment industry in Gujarat, going to be India's first climate controlled IoT, Internet of Things, and power over Ethernet building. So over to you, Amin sir.
Thank you, Farhad. Thank you very much for that introduction. And you know, when somebody introduces me like this, pay attention to what I'm saying. So, and I wanted to, you know, reach out to the audience before I launch into my presentation to you. I want to tell you a little bit about Chakresh ji. I met Chakresh ji in 1997. तो मेरे पास कंप्यूटर भी नहीं था, हम लोग हाथ से ड्राफ्टिंग करते थे, कैड के बारे में पता चला था कि कोई चीज होती है और अगर सीखोगे नहीं तो आगे काम नहीं कर पाओगे. एंड आई रिमेम्बर कि मेरी पहली क्लास के बाद यू नो चक्रेश जी सेड कि भैया देखो प्रैक्टिस से सारा काम होता है, प्रैक्टिस करोगे तो सीख लोगे, प्रैक्टिस नहीं करोगे तो नहीं सीखोगे. कंप्यूटर था नहीं, पैसे भी नहीं थे. सो आई टिपिकल वो इंडियन वाला दिमाग, आई वेंट अप टू हिम एंड सेड कि सर कंप्यूटर में ले लेता हूँ, लेकिन मेरा जो घर में टीवी है वो एंड यू नो it opened my eyes to the idea that there is an entire ecosystem. There's a way in which things get done. There's technology at the back of it. You need to invest in various kinds of systems and processes and equipments to be able to really you know, deliver value to your customers. And as a part of that value delivery, fortunately or unfortunately, what happens is that as a leader of the business, I get called upon to speak about the work that we're doing. But I want to tell you that there is this really brilliant bunch of people who actually do that work. On this call, there are two of my very important colleagues. So the actual data on the presentation that you're going to be seeing has been done by one of my design engineers. His name is Vipin. Vipin is on this call, and he is the man who is responsible for the actual slides and the videos that you're going to see. I also have Karan Gupta with me, who is our who looks after our corporate communication. So the way the presentation looks has been done by him. Karan, I think you can share your screen now, and we can launch into the presentation. I would like you to keep moving on the slides every 10 seconds or so. If I want you to go back, I'll ask you. Otherwise, I won't stop you from moving the slides. Karan, can you please share the screen? Thank you, Karan. So keep moving, you know, the slides every 10 seconds, and I'll keep speaking. So today's presentation is specifically about the ability of our software and this entire ecosystem that has been created under Revit to carry out analysis on building energy usage, and to be able to specify electromechanical devices that are going to control the environment in the building and the way the building behaves. The drawing that you see in front of you is a typical CAD drawing, stuff that you would find even today in lots of agencies, and it has the typical issues of coordination. It has issues of communication problems. It has issues of not being able to communicate fully the intent of the design, sectional disparities, issues with clashes and services, and so on and so forth. And the energy that we have, the time that we have to design a project is always finite. And if one is looking at these fundamental basic things taking up about 60, 70, 80% of our time, the time that is left for actually creating value in the project, where your intelligence and ideas and thoughts and engineering can create a value, becomes very little. And that is really where Revit-based environments come into play. There are several plugins that are available within the systems and the software, which are very simple. And the greatest thing about these plugins is that they are driven by industry data. And therefore, whatever is available in the market, whatever people are manufacturing, whatever systems are there, whatever standards are being currently identified and used, is already updated in the system, and you don't need to go. So the slide that you have in front of you shows one of our housing projects, and it has been stripped away at various levels to show how the electromechanical system, in this case, it's largely ventilation of the housing, how it works and how the air conditioning is going to work. Karan, can you please move a couple of slides? Karan, can you? Yeah, thank you. This is another project. This shows more of the energy management and the BIM systems that have been utilized. The slide in front of you is a project that has been completed last year. In fact, just about the beginning of the pandemic, this factory came online. It's a very important project, I believe, in the enhancement of systems and work that we do in India. This is about a 500,000 square feet manufacturing facility that has a 10-meter height. And to the best of my knowledge, this is India's only climate controlled manufacturing facility. So there is welding going on, there is cutting going on, fundamentally a lot of steel work going on. And yet the building does not cross 28 degrees Celsius indoor temperature. This is in Baroda. The outside has been touching 48, 47 regularly. Humidity also is very high in certain cases. How did we manage to do it? So obviously, the layout and how the building will behave, etc. These are things that all of you do for a professional living. That is what your job is. But as I said at the beginning of my presentation, one of the big aspects of time that is taken is coordination between various agencies and the ability to create drawings that will communicate your intent. And you realize that for the finer things in life, like being able to, really optimize energy, really understand how equipments can be optimized, how equipments will talk to each other, how the building management and control system will come together, that gets left over because all your energy has already been spent in trying to make these drawings. Now, in this building, we were greatly assisted by this entire software ecosystem based on the Revit platform and the various plugins. And of course, I must thank the Capricorn team because they were part of the initial training processes and the initial setting up of processes that we had done during 2017-18 when this project was on the drawing boards and being actually designed. This building has been able to make use of geothermal energy. So we were able to calculate the total kilojoules available to us for lowering of the required number of cubic meters of air simply by putting a pipe through the entire foundation system. As you can see, the building is very long. Currently, please carry on with the slides. As you can see, the building is very long, and we had close to about 400 meters of piping length available. So we simply embedded pipes in the foundation system at very little extra cost to the client. And we realized that the air that was going into these pipes and then eventually being thrown into the open spaces of the building was coming down by between 3 to 4 degrees Celsius at almost no cost. We had only just the cost of being able to suck in a certain number of cubic meters of air and then throw it into the building.
Hi, Amit. Sorry to interrupt. Your voice is cracking, so maybe you can switch off your video.
Okay, I'll do that.
Yeah, thank you.
Is this better?
Yeah, quite better.
Okay, all right. Thank you. I apologize for this. So the building, so then, we suddenly had this free sort of relatively cooler air available to us, which was 3 to 4 degrees Celsius lower than the ambient. We used it as the TFA input for the air conditioning system. So now the air conditioning system, instead of having to bring down air from say 47, 48 and bring it down to 24 or 26 or 27, depending upon where we were trying to maintain the temperature, was now bringing it down from 42. Massive difference in the energy consumption and the number of hours of running of the compressors. Apart from that, we also managed to then work with various companies, especially notably Blue Box and its associated companies, to be able to actually use radiant cooling in the floor. So what we've done in this building is that about 270,000 square feet of the industrial floor has PEX pipes inside the floor. And the return water which is coming back to the chiller in the primary circuit is used to is passed through a plate heat exchanger, and the plate heat exchanger then sends out water at about 14-15 degrees Celsius. By the time it reaches the floor, it's about 17 degrees to 18 degrees Celsius, and it creates a cool envelope which is about 2 meters higher than the floor. So while the building itself is 10 meters high, the human being is actually only about 1.5, 1.7, 1.8 meters tall. And you get this feeling of a cool environment within the building because you can see the radiant PEX pipes being laid just before the floor is being before the floor is being cast in. This was made possible because of the huge amount of analytical power that we had available to us once the fundamental Revit model had been completed. And because we had the ability to calculate, we could also go back to various manufacturers and tell them that this is what the simulation says. Now, can you please put in your equipment and prove to us that whatever it is that you've been advertising to us or whatever you've been claiming, itna temperature kam ho jayega, itna energy bach jayega, etc., is actually going to happen. So we've seen 2 summers in this building now, the summer of 2019 and the summer of 2020. And we realized that to the tune of about 90 to 92%, the predictions of temperature control and energy control in this building are being met. And what is really interesting is that the total air conditioned area is about, as I said, 274,000 to be exact, square feet. And the chiller is just about 450 tons. So for 450 tons of chiller, 270,000 square feet of industrial area is being generated. What this software also allows you to do is that you can simply pull out offtakes of all the equipment, and you can also interface these equipments. So the entire equipment start, stop, and operation procedure, which is part of the BMS, has been taken from the fundamental model that we had, and the overlay of how people were moving, how processes were moving, which were the hotspots, where the machines were kept, and which machines were going to generate a lot of hot air. Do we needed to exhaust in that area? How are we going to control? So a lot of architectural decisions about whether to place an area in isolation, whether to have panels around it, or to leave it open, or to allow air exchange or not to allow air exchange. How many units of air are we going to change per hour in terms of ACPH? What are we going to vent? What are we going to recirculate? All of it got very easily managed within the system without us having to break our heads or putting any kind of superlative effort in terms of number of people working. It might surprise you that the total electromechanical team that worked on this project, and the total project is about 25 acres of land, about 500,000 square feet of built up area. We had a team of only 11 engineers who looked after the entire HVAC, mechanical. Mechanical will include, pneumatics and hydraulics and so on and so forth, electrical, ELV, and PHE. And to the tune of 90 to 93%, whatever we had predicted in our DBRs has actually been achieved in this building. And like I said, I wanted to thank Capricorn, because at the initial part of this design process, we had people from Capricorn sitting in our office, I think for about close to 1.5 months, where they were sitting and working with our execution and design teams to be able to set up processes, to be able to set up workflows, and to be able to get coherent output out of the data input that we were doing. I mean, obviously, anything which is garbage in is going to be garbage out, and to be able to sift through the data that was available and to be able to get only those things that we really needed and made sense was possible because of this ecosystem. And of course, the great help of all of the teams that worked in it, including not just people from ANA, people from the software side, people from the process side, and our colleagues in the industry who do manufacturing. Now we have a phase two of the same building, which is being designed and is currently under construction. Right now, civil work is going on. And my colleague Vipin has prepared a small video, which is a process, a step-by-step video of how do you actually input data into this software, and you get an output in terms of not just the fundamental heat load and energy needs, but also equipments and equipment selections and so on and so forth. And I would request them to play this video. You can watch it. It's a short video. I think it's about 2 minutes. And that would pretty much be the end of my presentation. I'll be happy to take questions. Thank you, guys. Please go ahead with the video. Karan, the audio seems to have been lost.
You need to share the audio, Karan.
Karan, maybe you could replay the video, and the team would help us to share the audio as well.
Yeah, so click on three dots and click on share the audio, computer audio.
ये भी सॉफ्टवेयर पार्ट होता है कि कितनी भी प्रैक्टिस कर लो और कितने भी ट्रायल रन कर लो, फाइनली वो कुछ ना कुछ ग्लिच होता ही. So please bear with us while the team gets this sorted out. what you have on your screens is the menu. Thank you there, guys. It's a short video. I'm sure that the Capricorn team can also figure out a way of being able to share it with the participants later on. Basically, what the video demonstrated was we took a very small space in one of our buildings, and it takes the entire process from the analysis of that building when it is geolocated. So you know what geography, what alignment, what altitude you are in, which city you are in, and what the temperature backgrounds are, and the wind and the solar backgrounds. It carries out solar studies, it carries out thermal studies, it carries out shadow studies, does the heat load calculation. You put in the parameters of the fresh air that you want, and then it actually gives you an options of the equipments that you can specify, and you can run several equipments virtually in the system, and then be able to decide the best fit that is there for your client and for your building and for the performance of the building that you want. Now all of this, if you were to do manually or if you were to do on an Excel or the regular methods of doing it, would potentially take, for a building of the size that I just showed, it's a small building, it's about 20,000 square feet. I think conventionally it would take about 200 to 300 man hours. Versus if you use the workflow that we just showed you, I do not think that it's going to take more than about 20 or 25 hours of work. So you front end load your businesses with software and with process, but in the back end your bottom line is better and your client is happier because you're delivering to them something which is well thought out. And tomorrow, even during construction, 2 years down the line when it is being done, if there are queries, questions, ideas that are raised, you have answers for them. Or if technology changes between now and the time you're actually building, you've got a very simple, straightforward way of saying, okay, I can go ahead with the higher technology, and here is the simulation. This is what I can do. So from ANA today, this is what we have. I thank you all for being patient. I know that my voice was a little poor in the beginning. I've joined from outside the office, and I apologize to all of you for the inconvenience. I'll be happy to take questions. We can go ahead with that session now.
Thank you, Amin sir, for actually showing a practical application of using BIM for both passive and active design strategies for designing a sustainable building. So now I would request anyone having any question, please put it in the Q&A box. So I'll read out a few of the questions which have popped up. Okay. So there is one question from Mr. Sunil. How thermal properties impact the energy efficiency of buildings? how the evaluation is exactly done?
That's a very, very nice question. So as you know, all materials and combination of materials that we use result in a certain time lag in the passage of temperature between the material. So when we are looking at a building skin, the time that it takes for outside temperature to come inside, or for temperature to equalize between outside and inside, is the thermal transmittance value that we have. The transmittance value of individual materials is known. These are documents that are available from manufacturers and even from the internet. And then it is up to you to decide what combination of materials are you going to use. So depending upon the geography and application, you will decide whether you want a high thermal mass or a low thermal mass. Do you want to store energy, or do you want to dissipate energy? Or do you want a lightweight building which does not allow temperature differentials to happen? You know, one of the most brilliant devices that you have at home, which you can see and you will realize what it is your humble refrigerator. Inside, you've got a temperature of 6 to 7 degrees Celsius, but when you touch the outside, you don't feel the cold. So a tiny little compressor, which is taking maybe just about 200, 250 watts, is keeping that space at a particular temperature because the insulation value of the cabinet is very high. So you have to look at your building like a refrigerator cabinet. इसको मैं कितना insulate कर दूंगा तो मेरा internal temperature number one vary नहीं करेगा और number two बाहर की चीजों से affect नहीं होगा. So whether you are building in a cold climate or a hot climate or a mixed climate like Delhi, by taking a combination of insulating materials and a combination of the wall sections that you decide, you can also define the performance of the building. Once you have the performance of the building, comes cost. So then you take all these three. You take electromechanical equipment, the amount of energy that it will use to create the temperature or environment that you want inside, the materials that are available to you, and the cost trade-off between capex and opex. So how much money I'm going to spend in building in the beginning to reduce its running expenses, and you will always come to a sweet spot. That any money that you're spending, if the energy cost recovery is within about 3.5 years, you should spend that money because the building will live for 20 years. Equipments will live for a minimum of 10 to 12 years, and the client would be able to recover that money several times over. I hope that answers the initial query.
Thank you, sir. So one more question from Mr. Nabil is radiant cooling system is the main system to remove, or you have a backup cooling system to meet the peak demand?
Okay, again, another very interesting question. So a radiant cooling or a heating system is never a complete system. So while the temperature of the surface has come down, you still do not feel good because you do not feel an air movement. So unless a radiant heating or a cooling system is provided in conjunction with the air movement and fresh air system, you will never have a complete system. So it's not about a backup. What it does is that it takes away the amount of energy that you need to feel good. So you put about 35 to 40% of latent onto radiant, and then you also throw some air either using HVLS fan coupled with a TFA device or AHU device, and you allow also the person to feel a certain amount of air movement. Both of these things combined together will create the feeling of comfort.
Thank you, sir. I'll pick one more question from Mr. Amit Omar. What is the significance of sun path analysis?
I believe it is the generator of the form of the building as an architect. How much mutual shading is possible by the form of the building? Which functions are you going to put in the worst path of the sun if you're building in a hot climate, or vice versa? Which are the most livable parts of the building that you're going to put in the sun path if you're living in a cold area? One is of course the theoretical thing saying कि अगर साउथ में खिड़की खोलोगे नॉर्दर्न हेमिस्फीयर में कंस्ट्रक्शन कर रहे हो तो विंडो में सन आ जाएगा. एब्सोल्युटली ट्रू. कितना आएगा? या दिल्ली जैसी जगह पे अगर कंस्ट्रक्शन कर रहे हो तो मेरे को विंटर में सन अंदर चाहिए लेकिन समर में नहीं चाहिए. So how do I design the threshold and the length of the छज्जा? Now traditionally there are thumb rules which say कि अच्छा 600 mm का बना दो तो सब ठीक हो जाता है. You can take these data, and when you put them on a geolocated site and carry out a solar diagram analysis or a solar path analysis, you come up with really surprising results which can give you optimization of not just space but also volume in certain cases up to 15-20% also. Now imagine being able to simply shave off 15% cost on the fundamental envelope of the building. And obviously, लोगों की दुआएं मिलती हैं, people who live in that building will be comfortable for 20 years when you've designed it. So I think it's as important as your fundamental thought about what you want to design, and it's a generator of the form.
Right, sir. Thank you, sir. So I'll take just one last question. This seems to be interesting. How was the cost comparison done? How to prove the client?
No, absolutely. See, this is a very important part, and I had touched on it briefly in the second question. What we all as professionals need to understand that two things. Number one, typically, when a client embarks on a building project, for his or her organization, it is probably the largest capital expense that he's going to take. So if it's an industrial building, it will usually be the second largest because the machines would be the most expensive. And for most other kinds of buildings, which are residences, anything else, houses, offices, it is the largest capex. So firstly, one needs to understand that you're looking at probably the largest capex that a person or a group of persons will spend. Then there are market benchmarks to say, okay, so and so has done a similar project and it has cost him so much money. This is data available, dime a dozen in the market. The third aspect is, how much will it cost for me to run this building, to continue running the ACs and the lights and the various aspects of the building, the elevators, escalators, whatever it is that I'm putting into it, how much money is it going to cost for me to run? So the total cost of ownership is the OPEX and the CAPEX put together. And this is where experience, knowledge, and a lot of effort comes in to prove to a client that if you take conventional OPEX, conventional capital expenditure, CAPEX, your OPEX is likely to be conventional and therefore high. But if you spend 2% extra or 3% extra or 4% extra on your capital expenditure and drop your OPEX by 25%, you will recover this 4% over a period of 3 years, 4 years. So even if you are borrowing this money from a bank at an interest of say 12% or 14%, the building out of its operation will pay you back the EMIs in 3 years. But the building itself will last for 7 more years. So the building is actually earning you money, which means that if your competitors are spending 100 rupees a month running their building for the next 10 years, you would be paying say 60. So in the first 3 years, you've recovered your cost. And for the next 7 years, you're actually earning. When you talk to people about earning, it usually does the trick. But obviously, you have to be very, very sure of your analysis, because you will also be there and the client will also be there 2 years after the project's been built. And it'll be a shame to, get a call to him saying, कि आपने जो किया था वो ठीक नहीं है. But in most cases, if you've got your input data correct and you have spent adequate time in analyzing it, and as I said, we now have the tools to be able to carry out this analysis, you are in a very good spot to advise your client on how much capital expense, how much OPEX, how much are you saving, and how much the building will earn back. In fact, it's not become very popular in India, but in several countries, there are agreements that design teams are having with potential customers where they say that you don't pay us a fee, but we will take a percentage of your savings. So if your fee is a total of 20 rupees and the client saving is, let's say, 30 rupees a year, you tell him that, boss, I'm going to take 10 rupees a year for the next 10 years. So instead of 20, you actually have a potential earning of 100. And there's several interesting commercial spin-offs of this technology. This is not the forum for the discussion, but I just wanted to plant that seed. Somebody would take it up.
Thank you, sir. That was a really interesting example you explained. And so there are still questions coming up, but we'll note the questions and we'll send it to sir in email so he can reply later on. So now we'll move on. So I would like to invite Mr. Abhishek Mukherjee to start the demonstration of Revit and how to use it for energy analysis. Over to you, Abhishek.
Yes, thank you, sir. I'll just share my screen. Yes,
Yes.
is my PPT visible, sir?
Yes, and your
Uh,
voice is clear, so you can
okay,
start.
thank you, sir. So hello everyone, I am Abhishek Mukherjee. Let me just turn on the video. So I'm Abhishek Mukherjee. I am a BIM specialist architect in Capricorn, and I've done my bachelor's of architecture and I've done my master's in building services. So I'll be taking you through a concept called BIM, BAM, Boom. So you guys must be wondering that we are still in the process of learning BIM and what is this BIM, BAM, Boom, or what is BAM and Boom. So let's do a quick survey first. So in the bottom of your screen, you have a raise hand option. So whoever has not heard of this term, this is a term coined by architect Patrick McLeamy. He's the ex-CEO of HOK. And whoever has not heard this, can you please raise your hands? So we'll have about 10 seconds for that. So I see around 38, 40 people have raised their hands. They haven't heard of this term. So I reckon others are also in the process of raising their hands. Or maybe they've heard of this term. Okay, let's continue with this then. I'll explain what BIM, BAM, and Boom is. So the term BIM has come into common usage over the past few years. By definition, BIM is a digital representation of the physical and functional characteristics of a facility. BIM stands for Building Information Modeling, but BIM alone cannot deliver the promise of building information modeling over the building life cycle. So allow me to explain how. So think of the cost over time of a building, which is designed, constructed, and operated using BIM tools. For every rupee spent in design, we spend about 20 rupees or $20, or this is actually a ratio. So it can be rupees, it can be dollars. So for every 1 rupee spent in design, we spend about 20 rupees for its construction. And when we talk about operation, it goes up to about 80 rupees. So 1 is to 20 is to 80 can be thought of as the ratio. So the capital expenditure, that is capex, is several times more than the, or you can say the operation expenditure is several times more than the capital expenditure, thus creating more energy demand during the operations phase of the building. BIM supports development and testing of design ideas. BIM also supports budget and program compliance. Furthermore, the budget enables the compliance with energy goals, which is our topic for today. Now, contractors these days assemble manufactured building elements on site. In other words, precast elements are put together on site. Usually, this is the process which is going on these days. So now contractors use BIM as a building assembly model, or BAM. BAM allows better scheduling. BAM facilitates better subcontractor coordination. BAM supports cost control. BAM manages construction value, which is 20 times the cost of the design value. That is 20:1. That is the ratio. Now, during a building life cycle, the owner can leverage BIM and BAM to optimize building operation. This is called building operation optimization model, or BOOM. So this is how the term BIM, BAM, Boom has come up. Boom helps the owner manage energy consumption. That is the running of the various appliances, various building management systems which require more energy, HVAC systems, etc. It helps the owner with scheduled maintenance as well. So since Boom is managing a value of 60 times the value of design, that is 1 is to 20 is to 80, the cost savings potential is enormous. So now the real promise is of BIM is better design, better construction, and better operation. In short, BIM, BAM, and Boom. So let me move towards the topic of passive design strategies and active design strategies. So from college days only, architects are learning about passive design strategies and active design strategies. So what is that? Passive design strategies are those strategies which, like orientation of the building, or we can say using some building materials which will actually help us to achieve a better thermal comfort. So it would result in less initial cost. These changes are permanent because they are inside the building only. Then less maintenance cost of the building, no or minimum running cost, environment friendly, aesthetically appealing, and planned at the initial stage of design. This is very important when we talk about BIM as well, and how BIM will help in achieving these passive design strategies. I'll be discussing about that also. And there are few active design strategies also, like you are actually incorporating HVAC systems, fans, etc. This is for heating and cooling. And if you are using more of artificial light than daylight, then you can also call that as active design strategies. So high installation costs, they are not permanent always. Sometimes they are. When we have high maintenance cost, high running costs, they are often not aesthetically appealing. Like for example, the designs of 1980s, 1990s buildings did not have the did not cater to the outdoor units of ACs. So now they have spoiled our facade. So all of these things are adding up if we go to active design strategies. But having said that, we need a combination of both. But we actually try to rely more on the passive design strategies than the active ones, so that our building running cost reduces. Now, how does BIM and sustainable design relate? Architects play a major role in planning the passive design measures. In the traditional 2D CAD workflow, architects use the prior experience and presumptions for deciding the orientation, number of fenestrations, and materials in designing a facility. This process lacks substantial data to justify the impact of passive design measures taken by them. So if you are using a 2D workflow, maybe you are going by experience, you're going by gut feeling that, okay, west side is the side which will receive maximum amount of sun. So in Indian context, you will probably have less amount of fenestrations over there. In a place which is cooler, maybe in Europe, you would probably want to have more sunlight in. So you'll probably have more number of windows on the west side, and likewise. However, by making a 3D model with intelligent data, architects can run analysis and derive the outputs in order to achieve thermal comfort. So good passive measures will ease up the load on the heating and cooling system. And that's what we want. We want to save and conserve the energy at the operational phase of the building as well. So sustainability need not be only at the construction phase and the design phase. It has to be on the operational phase as well. And here's when BIM BAM boom actually comes into play. So allow me to now show you the shadow analysis. How do we actually show the shadows? So I'm just opening this file in Revit. Here I'm going to the Manage tab. In the Manage tab, I'll go to the location. So first we need to set a proper location. So for this, I'll be using New Delhi. And when I go for searching for New Delhi, there'll be a small tab which will tell me that, okay, this is New Delhi. I need to search that. And I have the pointer which I can drag now to wherever the exact site is. If you have the coordinates, then of course you can place in the coordinate value as well. So we need a proper location for the shadows to be actually working. So then I can set the weather data also. And I see that the closest weather station, that is submerging area in Delhi, has been selected. Then the dry bulb, wet bulb, and mean daily temperature, mean daily range of temperature has been there. We can also, for optimization of design, change a few of these values, because of course HVAC designers will not take the average of the month. They will probably take the higher values or the lower values, whichever is relevant for that. So I can just click on any one of those things, and then I can just change the values as it's shown here. Like I can change the May temperature to be lesser or more. This is a manual thing. Then I'll click on OK. Once this is done, now I can go for the shadow analysis in Revit. So shadow analysis is not just still shadow analysis. It can be in the form of an animation also. I'll just open the hidden line view here. And from here in the bottom left corner of the screen, I'm just going to the sun path or sun settings. Right now, I need to see what sun settings I'm using. We can go for a still. We can go for a single day sun setting also. We can go for a multi-day sun setting, or we can also go for the lighting, which will specify the azimuth or altitude angle of the sun. So all of these play an important role while doing shadow analysis. So I'll go for still. I see that the location which we had set earlier on, somewhere near House Khas in New Delhi. So that has been picked up directly. Then we can set the date also, whichever one we want to specify, like 2021, maybe February, maybe March. And then we can go for specifying the time. This is the still setting. So in this setting, we can just apply and then click on OK. And we see that at this point of time in this latitude and longitude at this location, this is what the thing will look like. Then I switched on the sun path. So this is the sun path diagram, which is specifying the date which we just specified over there. And we can change the date from here also. both the things are correlated, and we can set the time as well. You see there's a small depiction for sun, and I am setting this. We can just drag the sun also, and the date will change accordingly. If we drag it across the line, then the time will change. So accordingly, the shadows will change in real time. You need not do any kind of presumptions or based on previous experience. You are actually having the real time values, which it is showing right here. So whatever the date is, you can specify here. Whatever the time is, you can specify, and then you can directly take maybe a screenshot of it if you, or you can export it if you want to have a still view. But once you want to just have an animation of this, you can go to sun settings again, then click on the single day. So for example, you want a single day solar analysis of how the sun is going to travel from east to west. So from sunrise to sunset, just increasing or decreasing a few hours maybe. And then we'll set the time interval to 15 minutes. That is the lowest which we can get. And then what I'll do is I'll select OK. So after doing that, I can go to preview solar study. So we can preview directly inside the software as well. And when we play that video, you can see how the sun will impact your shading. It is being directly shown over here. So this is just a small demo as in how it will look from the aerial view. But right after this, we'll have a view which is closer to the building, and then we can see how things will change and how the actual human eye view would look like. So I'm just going to the view tab and then selecting the camera option. So in the camera option, I can just click on the camera and specify as to how much of the building I want to see. So just place the camera, go there, and then just leave the camera on the other side. So this is kind of an eye level view. I can make some adjustments to this view. Just dragging a few points maybe, or just using some options like crop view and all. So here I see that there's this, there's a small shading from the trees also, and then there are a few building elements, and this is kind of a human eye level view. So now when I switch on the shadows, you see this is how this will work. Again, I'll go to the sun settings and then change a few settings so that I can do a single day solar study. Again, setting the date and setting the time, and then finally setting the interval of 15 minutes. So now when we preview the solar study, we'll be able to exactly find out how and when the shadows will be appearing, and which probably will help us in making better design decisions, that whether we want to have sunshades, whether we want to have an open courtyard, whether we want to have some covering over the courtyard, and likewise. So these kind of decisions are actually very helpful for us. That's because we can, in the initial stage of design, take some decisions. I can export the same to maybe this thing, solar study kind of animation, which will be an MP4 animation. And I'll be setting the frame rate per second. I can set that. And then just click on OK with the existing settings. So it's an AVI file. So after setting it, we just click on OK multiple times. It will take a few seconds maybe to, yeah, it's taking a few seconds for processing. And then after that, we can just go to any of the folder and then view it as a video. So this is how we'll be able to do some of the initial decision making and maybe take some decisions on whether we want a facade which is full of glass, whether it is shaded or not, and so many passive decisions which will be dependent on the shadow analysis. So this was a quick demo on the shadow analysis. So this is it from my side. So I hand over to Farhad sir. I'll stop share.
Thank you, Abhishek. So now I invite Nazim to give further demonstration of Revit and the Insight. So Nazir, if you can share your screen.
Yes, sir. Is my screen visible, sir?
Um, yes.
Okay. So I'll just make it pretty as well. So good evening, everyone. So I am. My name is Nazim Khan, and I am a BIM evangelist in MAP, and I am going to cover the topic of BIM and Revit for energy analysis. So how do we actually how do we utilize the tool? So in the presentation and the session that is left for now, I'm going to cover most of the tool and the utilization of tool to get our better results. So it's BIM and Revit for energy analysis. 1 second. So yeah, so one of the most important factor and benefit of using Revit is that we can utilize Revit to do energy analysis at any stage. Let's suppose we are doing energy analysis at conceptual design stage. We can do the energy analysis at the conceptual design stage when we do not have the entire details, when we do not have the entire model complete ready. We only have conceptual design. Then also Revit helps us to do energy analysis. And obviously it saves a lot of time. We see this curve, we understand that at the initial stage uh, we have a very less cost associated to change and a huge impact of an influence of our changes, which which is vice versa when we go towards other further construction stages. So as the construction stages go to next and next stage, by the time we reach to the execution stage, any design change will have a major cost of change and very less major influence of design. So yeah. Now, next is that we understand that there are a lot of advantages and benefits of doing energy analysis at a early stage. We can get integrated analysis and modeling. We can run different analysis and we can compare performance of alternative design strategies. And early stage design decision have great impact on building performance. So these are some of the. So I'll first try to cover the heat load analysis, how we can do heat load analysis in Revit, and what are the benefits of it. So we know that when we talk about heat load is one of the major, it plays a very major role in the entire energy analysis, because we know that it covers highest percentage of the heat impact on the building. So it has great impact on energy uses and saving. Directly, indirectly, it is linked to other factors, and it can be controlled by various measures. So we have, if I talk about theoretically, I'll just take a few seconds to divide the entire heat into two categories. So we have some of the external heat gains, which is coming through walls, roofs, and other the facade of the building. And one is internal heat gains. We have electrical equipment and other things that are accounting for internal heat gains. So we need to calculate both of them. So this I'm going to try. I'll try and show how we can set. So this is the Revit model, one of the Revit models that we have. And if I try to show, for example, this is one of the space we have. So in Revit, we have analysis tool, which does all the kind of analysis that we need to do. Uh, it, it does all the energy optimization, energy analysis, and spacing and zoning, and we can calculate heating and cooling load that I'm going to show you now in the coming slides. So first of all, we need to identify the space that we are trying to see what is the load on that space. So let's suppose we create this space and we see the information of the space. This is one of the most important thing. And in the space, we have one section for energy analysis. Okay. So here the two factors that we talked about, the internal heat gains and the external heat gains, they are categorized here. So in one, we have space time. Unless and until we understand what kind of space we are dealing with, we won't be able to, get the total factor out of it. So for example, if we are using, these are ASHRAE data. If you are aware about ASHRAE data, we understand that ASHRAE provides all the standard data related to internal heat gains and some of them related to external heat gains also. So for example, if I am designing, if I want to see what is the total heat gained by my office space, then, for office, it gives various parameter and values for the energy analysis. For example, if generally in an office, one person will occupy something around 20 meters square. That is a standard parametric value that we have from ASHRAE, let's say. But if I want to change, definitely I can change. So Revit gives us leverage to change as per our requirement also, to customize it as per variables, different variables also. So we have all the internal heat gains, for example, sensible heat gain, latent heat gain, and these are also changed. We can change these values. So, and plus in internal gains, we have lighting, we have power, we have infiltration, plenum lighting contribution, and then schedules are also very important. So we have all the schedules. We can create new schedules using these values, and we can give various values to various schedules. So we have occupancy schedule, we have lighting schedules, we have power schedule. We all, people who are who do keep on doing the energy analysis, they will be able to connect with me. Otherwise, I'll just tell you that occupancy schedule plays a very important role for understanding how much the energy is consumed by the building over a month, over a year, or over a life cycle cost. So over a life cycle. So here we can categorize it, and we can easily change it also, customize it. Then we have infiltration, ventilation. These things also can be changed. So these values are standard. We have standard, and as we change the area, for example, area per person for office is 20. If I change it to playing area, it is going to change to 3.33. So apart from that, I come back to next very important thing, that is the U value and the R value. So the external loads, they are coming from roofs, exterior walls, interior walls, ceiling, and all the facade area and glazings and all. So we have, we can, so these are some of the values that we have, and there are multiple values that we have. A U value for a flat roof, that is something around 0.2497, and for a different kind of building material used in the building, it is going to give different U values. Okay, ranging from 0 point something to 2 point, as we see here, as the material changes. So that is one of the very important factor while designing the building. We need to consider, we generally consider what is the material we are using, and one of the most important factor for the material, building material, is R value, which is inversely proportional to U value. So R value has a relation with U value. So that is what is going to, if we can fine tune the values, it is going to definitely give us the approx nearest value of heat gains that we are getting. So we can set for all these, and if these models, if the model is created, architecture model is created, and all the values are given in the architecture model, we can utilize those values instead of giving values here. Then we have shading factors or for exterior windows. So these values, which are very important. And plus, I'll just like to add one more thing. So we have these values which are fed into the Revit, but there are possibilities we can, so Revit has a API also. So there are possibilities of putting our own values if we need. Okay, so yeah. So if we have been able to successfully define number of people and occupancy, heat gains and everything, electrical loads that we see here, all those things, if we are able to define, and we can also at the same time do all those things. So if we have defined it, we can generate a report like this. I'll just show you the report, how detailed report we get. So it will give us the entire load that is generated on the building. So just yeah, so this is the report. So this is a load summary that we can generate from Revit. So it says that total load on the building, total cooling load is something around 388 kilowatt. That is equivalent to, so this unit can be changed and we can get it into tons also. And at the same time, one of the most important factor is the cooling load we are getting on the building, and then the flow. So we are getting the flow also, airflow. What amount of airflow can we achieve? And this is going to play a very important role. Apart from that, the entire report is categorized into spaces, into zones. So these are the spaces that we have, and we can define it as per the elements. So how much heat we are getting through the walls, through the windows, and through other things. So we can, so if we are getting all these results parameters, then we can, take decision based on that. Okay, we are getting a lot of heat from the building, so we need to look at what all alternatives we have for the material, for the orientation, other things. So they're very useful for both architecture, from architectural aspect and engineering aspect. So apart from that, I'll just move on to another thing. I hope this is explained. So I'll show you another slide. So now our next slide deals with solar analysis. So solar analysis plays a very important role in the current scenario. Because we want to make our building more sustainable, and we want to utilize the alternate resources as much as possible. So we have an internal tool called solar analysis in Revit. I'm going to show you on Revit. So what it does, it helps us in tracking solar radiation potential. So we have, if we look at the facade of the building and we want to find out that how much solar energy can we gain using what part of facade. So for example, if I only want to utilize my roof, or I want to utilize my walls also for using the panel, so I can take those decisions. So that is called solar insolation. So so it uses surfaces on a model which can be created from standard architectural elements. So I'll, and it gives a value like this. I'm going to show you in the coming slide. So let's suppose this is a model here. I'll show you on the other model also, if possible. So here, this is the model that we have. And if I want to do the analysis, solar analysis, so I'll just, second, just allow me a second. I'll try to show you here also. Okay, fine. So I'll just turn on the coordination view. So this is the building we have, and I want it in Revit. We have, like I said, an energy analysis inbuilt tool we have, and one of that is the solar analysis part. So I just wanted to shade it. So in the solar analysis part, when I click on this, I get the value. So let's see, it is taking a few seconds. So I get this value. Yeah, so here we have uh, we have various study types, so we can customize it. So what exactly we want to achieve, that is something we need to know. What is, why are we exactly doing the solar analysis? That should be very clear. So if that is clear, let's suppose we want to see the solar energy annual PV. Okay, so I take that, and after that, then I have to finalize, do I want to only analyze the roof surfaces? So I have one value. The second option is surfaces. Either I can take customized values, or I can take all roof exterior surfaces. So I'll show you. Yeah, 1 second. It's taking a little time. So meanwhile, I'll show you this. Okay, so that, let's see. So this solar analysis tool that we have, when we click on that, it gives a dialog box which we have here, and here we can see that you have various study types that I showed, and then you have all roof exterior surface that I showed, and you can do user selection also. So depending, if you want to do user selection, then you can, by selecting, by mouse click, you can select which all areas you want to see, how much solar uh, uh, insolation we are getting over these surfaces. So let's suppose I select all these facade, all the glazings and wall surfaces, and this is going to calculate and give me the amount of area that I have selected. So let's see. Yeah, so I click on this finish here, and after that I have to do the sun settings that we have. So solar study we can do for single day, and we can set the timings. We can set the uh, variable of if we want it for summer solstice, and for time interval also. All those things, ground plane, other things can be set. It can be customized as per our need. And obviously we have, the location can be changed. We have already seen it, how to set the location in the previous slides. Yeah, so analysis grid is also very important. We can set what is the grid size, because that is something people who are, who keep on doing the PV analysis, they will understand the importance of grid size, and what is the result that I need, the unit that I need the result in. So if I want cumulative, or I need peak hours, or I need average hour, so I can take the type and the unit also at the same time. So we have British thermal unit per feet, square feet, and watt hour. So generally we are interested in watt hour, because we also have, at the same time, we want to see how much energy are we getting back. So kilowatt hour is a very important unit generally for us. All right. So I'll just skip it. So we have various variables. We can change the colors as per our need for the scale that we are going to get. And it is all customized. Depending on what kind of presentation we are looking at, we can change these depending on the variable. So again, that depends on the kind of project and the size of the project also. So we'll put it on analyze. And so at a very in a very few seconds we'll get the entire value. These colors, they signify the amount of, in what are per meter square, we how much solar insolation we are getting, and we getting the result here, and it can easily be seen here in the scale. So it becomes very easy for us. So we can see that a lot of heat we are able to gather on the roof surface, but internal facade it is very less. So that is around in the range of 49 watt hour per meter square. But here on the top we are utilizing it. So we can take a decision of whether we are going to put PV panels on these facade which are with lower solar insulation, or we will do value engineering and we'll finalize, take a design decision that we want these areas are useful for us, and we'll utilize PV panels on these areas only. Yeah, so okay. So I'll show you here also one more important thing. That is, if I, let's suppose I update everything. So I'll show you one more important thing that is there, which was not shown in that slide. So, okay, fine. I'll click on finish. Yeah. Okay, so again, it's taking a little time. We'll come back to it. Meanwhile, I'll take you to another analysis, which is one of the very important analysis in Revit, which is generally, looked after for every building. So let's see, that is daylight analysis. So that is, we also understand that daylight analysis is also very important part. So because again, the thing is that we want to utilize because we have to see the ratio between the artificial lighting that we are going to use and the lighting that we can use from the daylight. How much daylight can we use, because we have to achieve a lux level. Okay, so let's suppose if we want to achieve a lux level of 250 lux in that space, and we are able to get a value of something around 100 lux from daylight, then definitely we only need 150 lux from artificial lighting. So that decreases the amount of energy that we are going to use through electricity. So that plays a very important part. And then we can take a decision of, okay, we want to increase the daylight or we want to decrease the daylight. So we can take that decision. So I'll show you this slide. So again, we next to solar, we have lighting analysis, and there are various parameters on which we can do it. And we are every year updating it. You can do daylight analysis as per lead also, various factors as per beta also, and other things also. So we are updating every year. So that is the good. So yes, so we have taken a luminance lighting analysis, and so their analysis, we have 2009 lead, and we have other solar access also, daylight autonomy also. So we'll take this factor, and then again, if we have already set the location and we have set the solar settings, we do not need to set it again. We'll utilize that. And then we need to, look at other things, like what all levels we are interested in. We can take all levels. We can take entry level if you want to go step by step. And again, this is location. So yeah, and then one of the very important thing is that the sky model that we are going to use. So because it is going to change from location to location, so and our input also, requirement also, so we can change these. We can change the solar data. We can manually feed it, and then we have luminance setting, analysis plane height, at what height you need it, and then foot candela, instead of lux we are using foot candela here. So what is the lower and upper, that is a scale reading that we are going to see. So once these things are set, we'll push it on the cloud. These things are all done on cloud, so it saves time for us to do work also meanwhile. So we are going to, so once it is generated, it is going to show us this result, that result was generated on such a such date, and we can see, and we can compare also various readings. So this is one of the report that we got, and we are able to, so you can see that in this we are getting the maximum lux level here on the near part. So we need to see the design. So we have facades, we have glazing, and we have wall material. So it is going to vary. So here we can see maximum input of lux we're getting here, and near to the window area generally, and glazing area. And here green part is next to it, a little lower than yellow part, which is between 2071 to 4036. And minimum is this area, which is staircase, we can see next to that, and this area next to another staircase. So we are getting the least area. So we can take decision based on that. If if these are not meeting with our requirement, and we want to change it, customize it, we can easily change it anytime. We can change the settings, we can change the timings, we can change the orientation and all those other things. So we have here, I'll just show you one more thing. So here we can change the radiant also, as per the study. So we have, as per lead v4 also, we have lighting analysis radiance also. So we can change, and these are all customizable. We can customize it as per our style. Now, next important thing is that we have something called as energy setting, because next part that I'm going to discuss is Insight, Autodesk Insight. So to be able to get a very good result on Autodesk Insight, we need to put some good time on energy settings. So Autodesk Insight, it is an online building performance analysis software. So like I said, most of the things that I have showed till now, except for heat load analysis, most of the other analysis are online building or cloud based. So this insight, empowers architects and engineers to design more energy efficient building. Now, how, that is the question. So we'll see this slide. In this slide, we'll see this is the interface of Insight that we are seeing right now. So I'll show you. Suppose I close this. So here we have energy optimization option. So Revit model, once it is created, even if it is a mix of conceptual and building material that we have, we can do energy settings. All right, so here you have energy setting. I'll quickly go through this slide. So here we have, you need to set up your input. These are the inputs that we are going to give. And based on these inputs, we are going to get the report, parameter, and analysis done by Autodesk Insight. So we have, what is the mode? Does our model have only the building element, or it has conceptual masses only, or it has a mixture of a combination of conceptual mass and building element? Based on that, we are going to get the result. Now ground plane is very important because the grid plane is important for the analysis, for the heating also, analysis also, and other analysis also. Now project phase, we'll put these inputs. So these, some of the inputs are based on the project schedule. Next important thing is, which I want to focus on, is advance option, where you can set, like, let's suppose you are on the conceptual stage, you have not created everything, but you can still put a parameter, input parameter, of what is the target percentage glazing that that you're planning in your mind, so in your design, for your design. So you can put 40%, 30%, whatever you want, and target sill height, glazing is shaded or not. So these are input required even in case of conceptual model. If you have, so it will, Insight will take the input from here. And then we have for skylight also. So if you have skylight also, at the same time, we can put these values here also. Apart from that, we have building type. And the next thing which is important is HVAC system. So what is the HVAC system that you're planning? So are you planning for a central VAV? Are you planning for VRF? Or are you planning for CAV, or any such system? So we have a lot of other system available. This is only for information, initial information. So we have outdoor information also. So these are information which are going to be required if you have not created the entire detail of the building. Oh, second. Uh, yeah. So here we have outdoor information. So we all understand that for the occupant inside the building, outdoor air plays a very important role, because if you're sitting in any space, and if the same air is being circulated again and again, that creates a bad environment. And if we want a lot of air from outside, that creates a lot of load on the building, because it brings a lot of heat also into the building. So these information that we are seeing here in the energy setting, they plays a very important role, from the glazing ratio and building type, kind of air conditioning that you're planning to use, outdoor air information, and other things. So these things, once these are all the information are fed, we can push this model onto cloud by using this generate option. So we have generate. What this generate does is, it pushes all this model, which is a conceptual model, or it's a combination of conceptual and building. It will push it on the Insight. So the moment I click on it, it is going to give me a message that energy analytical model needs to be created before an energy simulation can be run. And then so let's suppose you click on this, I want to do that, let's suppose. Then it gives you another message that your model is being uploaded on the cloud. You just need to wait a few seconds before you get another. So you'll get a mail that your model has been uploaded, and after some time you'll get another mail that your analysis has been completed. Once that is done, you'll see a report like this. So you can log into Insight generally only by going to your web browser. If you're using Google Chrome, just you have to go there and just type Insight 360, Autodesk Insight 360, put your login ID and password, and you'll see a screen like this here. So this is Insight. And now this is a model that is uploaded. And it is going to show you, the overall operating cost of the building. So now it is showing a lot of factor. What are the factor which what are the important factor that plays important role in the energy analysis of your building? Let's suppose first I'll start with building orientation. So here, when you click on it, it is showing you that currently whatever the you're building in the whatever your building is in the state of regarding the orientation, it is generating energy cost mean of this much. Now if you change here, let's suppose you want to see, you just want to see if I do 180-degree, will it change? So it will change here. So they're not major changes that we see here because of building orientation that we have, but you'll see in the other things, other factors. So we have southern wall. Let's suppose we are talking about southern wall. Depending on the window wall ratio we have used in our model, Insight will suggest us that okay, let's suppose we click on this, so it gives us a value. So it says that, currently as per the window wall ratio of your southern wall, this is the amount of operating cost that is being generated. So if you change it, let's suppose to 0 here, so it is going to decrease or increase. If you do it here, it is going to increase, obviously. So because if you increase the ratio, then obviously it will increase. So that is going to, so it is giving you suggestion also at the same time. So we have for the shades. So the height of shade that you have used. So you see here it says if you use a window height of let's say 1 by 3, it is going to reduce. Like the overall cost, operating cost is going to reduce for your building. And if you keep on using, increasing it is going to decrease the overall operating cost. So this is the best we are getting here. So we can play with the variable. So one important thing is wall construction, let's suppose. So you have various values here. So this is the current state and these are various values. So if the wall is uninsulated, let's suppose I click on this, if the wall is uninsulated, it is going to give us the cost of energy cost mean of this thing, this much 9.44. And if you keep these material, like we have different insulation material, R2 12.25-inch SIP, wood, and other materials that we have here. So it is going to show you that how much can you reduce by using various materials. Similarly for infiltration, we have the same thing. It tells that you are using 0.4 ACH air change hour and how much you're using. So these are going to play a very important role. And these are all very important. Like if you use more of daylight and occupancy sensor, then obviously it is going to reduce the overall energy mean cost. For HVAC, what kind of HVAC you are using, and based on that, so if you use this system VAV, let's suppose, it is going to increase, it will have a major impact on your cost. And if you use another system, like high efficiency system, it is going to have a major impact on your building. So same for PV payback limit, it is going to tell you for surface coverage, for panel efficiency. So it is going to give you overall, in your building design, all the components is going to touch, and how can you make your building more efficient and more green, let's say, in terms of, and how can you save more cost over your building on the operating cost. That plays a very important, Insight plays a very important role. So that is all from my side. Thank you all. I'll hand over to Farad sir.
Thank you, Nazim, for such an elaborate session on Revit and Insight. So we'll now open for the question and answer. I would request everyone to please post your question in Q&A box. I already have a lot of questions, around 30. So I'll just take up few important questions and then rest of the questions I'll will reply via email. Also, there were a lot of questions on recording. So we will send you the recording on your email ID, recording link. And if you don't get it, you can write at connect@capricorn.com. Okay, so I'll just read out the question. So Nazim and Abhishek, you need to answer them. So one question is from Mr. Nabil to Nazim. So can we model systems in Revit like radiant heating and cooling systems, which can be coupled with heat pump, which works in heating and cooling mode.
Yes, we have in Revit, we have the capability. We have all the some of the families that are like heat pump families are there, and we can run the analysis based on that also. And for the radiant also, we have those families, so we can model it and we can run the analysis also. So we have we have the capability to do that. We can get, or at the same time, we can get the heat impact or heat load impact of that into our model. But I would also like to add that Revit alone, it does a lot of work, but it also has a great interoperability with some of the CFD simulation. So there's another one, Autodesk CFD is another software. It has very good interoperability with Revit. So once you have developed a model and you can do early stage and some later stage analysis within the Revit also. But if somebody wants a very detailed report, then they can push their model from here and they can put it on Autodesk CFD, and they can generate a better report regarding all the flow thing and even how the how the entire heat is you know you can visualize it, how the entire heat is distributed into the building at various part of the space.
Thank you, Nazim. So one question from Mr. Sanjeev Verma. Can we do all simulations for green building on Revit? So I think he means that if you are applying for IGBC rating, LEED, or GREHA, can we do all related simulation required by the rating system through Revit, or we need something else?
So, like I said, we can do for example, if we need Greha rating, lead rating. So the type of analysis, like we need daylight analysis, we need a heating analysis, we need there are different solar analysis and other analyses are also there. So the major point is that Revit has capability to run a lot of analysis, and it generates a very good report. But there are other software also that like. For example, I discussed Insight. Insight is very important, and Autodesk is developing Insight. And there was another software which is being developed again with Insight. So the amount of electricity used, you can put the input of what is the total amount of electricity in unit and other things. So we have to, because we are using BIM, so we have to use some other software also. And Revit has a great capability and interoperability with some other softwares which are for energy analysis. So I would say that we need to go out of Revit also at the same time, so so that we can actually do the entire process.
Okay. Thank you, Nazim. Then question from Mr. Bharat. Is the cost per unit data on BIM 360 Inside based on locations?
Location also plays a very important role. I mean, it's not only location, but it depends on location also. And there's a factor of putting unit rate, and you have other factors also. So location is one of the factors. It is not the only factor. So whatever cost we are getting at the end of the day, because in Insight there's also there's a parameter we can feed in the information of input unit and other things. So location is one of the thing, but location is not the only thing. That's my answer for that.
Okay. So we'll take two more questions. Does Revit has an IESVE plugin?
Yes, yes, it has. I mean, IES actually, they have done we were in talk with them. So they are using the Revit. So if you have developed a model on Revit, you can definitely, there's a plugin actually for ISVAs. You can utilize, so you can utilize the model you've used on Revit. You can push it on ISVAs and you can utilize it. And there's a great plugin and it has good interoperability.
Okay, last question I'll take. The rest of the questions I'll will answer through email. So can we get the same analysis report on models imported initially built on other softwares from other modeling softwares like SketchUp and Rhino?
Abhishek sir, I think you can take this question. You're an expert on SketchUp and other things.
Okay, so basically what happens is any other software data which we bring into Revit will be acting as a mass. So that mass needs to be given some properties in order to actually calculate some of the values which Nazim sir also said. And if we cannot convert that into as in an element of Revit, then those values cannot be calculated. So it's the interoperability of SketchUp with Revit is not that great, but instead if you go for Format with Revit, it will be a better option. So Format is just like SketchUp. It's developed by Autodesk, and it's a conceptual modeling software just like SketchUp, where we can set in locations and do some prior energy analysis also over there. So we can consider Format and Revit interoperability to be better than SketchUp and Revit or Rhino and Revit. So if you bring in the model from Format to Revit, it will be a good option, and it will be interoperable.
Yes, thank you, Abhishek. So obviously it is great to start with proper BIM software only rather than using any modeling software and then adding information. That is double work. Okay, so the rest of the question we will answer through email, and we have few other events also coming up. You can send the request at connect@capricord.com. And from on behalf of Capricord, I would like to thank especially architect Amin Nayyar and his team, and all the participants who took time and attend our webinar. So stay tuned for more such detailed workshops coming up. And obviously you can check from our website designaddvance.in as well. So thank you everyone and have a nice day. Okay, bye.